Hello friends, let us take the topic of area by using double integration. So if you have any curve, like say if it is like this, and suppose if it is a region bounded by these two curves, say suppose, and if you want to find out area of this region, say, so suppose this is say y equal to f1x, and this one is say y equal to f2x. And this is a point of intersection also. So if you want to find out the area of this region, the formula for finding the area of the region is like this: double integration a dA only. Okay. Uh, Find the limit from this region. So say suppose in this case you may have like this, say y equal to f1x to f2x, x equal to some a to b, and dy dx. You may also write, say, some x equal to f1y to f2y and y equal to some c2d dx dy. In short, the function that we are having in this integration sign is nothing but 1. So it's a very simple integration, and we can easily solve the example. Let us take one simple example. Find area of the region bounded by the parabola x equal to y square and the line y equal to x. So here the curve is, so y square equal to x and y equal to x. So we have y square equal to x. So that is a curve, and y equal to x. So the line y equal to x. So this is the portion that we have. Okay, so this line is y equal to x and this curve is y equal to x square. We need to find this point of intersection. So if we solve this, then we have x equal to y, x equal to y square. So y equal to y square, y into 1 minus y equal to 0. So y equal to 0 or y equal to 1 and y equal to x. So this would imply x equal to 0 or x equal to 1, and therefore points of intersection are 0 0 and 1 1. So this point is 1 1. This is 0 0. Now if we take the say vertical strip, we need to find the limits. So if we take a vertical strip, we can find the limit like y equal to x to y equal to x square, and that strip move from x equal to 0 here to x equal to 1. And so therefore, the required area A equal to y equal to x to x square and x equal to 0 to 1 dy dx. And so x equal to 0 to 1, this integration is y, and y equal to x to x square. So now x equal to 0 to 1, this is x square minus x dx. So x cubed by 3 minus x square by 2, x equal to 0 to 1. So 1 by 3 minus 1 by 2. And so that is nothing but 6, 2 minus 3 minus 1 by 6. But now here you need to take care. You need to take care is like this. Here we get the answer negative. So the area A is modulus of I, where I is this. So required area A equal to 1 by 6. You have to make it positive. Okay. So we take another example. Find the area of the region R enclosed by the parabola y equal to x square and the line y equal to x plus 2. So now here the parabola y equal to x square and y equal to x plus 2. So we have the curve like y equal to x square. So this is a parabola that we have y equal to x square. So this is a parabola y equal to x square and y equal to x plus 2 line. So it passes through if x 0, then y 2, and if y 0, then x minus 2. So it is like this. This is 2. So this is the line y equal to x plus 2. So we need to find out these 2 points, this one and this one. That means we need to solve the curve. So first thing is solving this y equal to x square and y equal to x plus 2. So x square equal to x plus 2. X square minus x minus 2 equal to 0. So minus 2 minus x minus 2, x plus 1 equal to 0. And therefore x equal to 2 or x equal to minus 1. And y equal to x plus 2. So y equal to 2 plus 2 is 4, or y equal to x minus 1 minus 1 plus 2, 1. So therefore, points of intersection are x2, y4, x minus 1, y1. So this is minus 1, 1, and this point is 2, 4. So if I take, this is the region of integration. Now here, by looking to this region of integration, it is advisable to take the vertical strip. That means limit of y first, because if we take the horizontal strip, that means limit of x first, then we need to break the region from here. Okay. So then we have two different double integration to solve. So it is better we take the limit of y first and then the limit of x. So limits. So y equal to, here on this curve parabola, to y, other end is on the line x plus 2, and that strip move horizontally from x is minus 1 here to other side x is equal to 2. This side x is 2, 2, 4. So therefore, required area A equal to y equal to x square 2x plus 2, x equal to minus 1 to 2 dy dx. So x is minus 1 to 2. This integration is y, that is x square 2x plus 2 dx. This is x is minus 1 to 2. This is x plus 2 minus x square dx. So now the integration is x square by 2 plus 2x minus x cube by 3. X is minus 1 to 2. So if I take 2 here, so 2 square is 4, 4 by 2. So that is 2, 2 here, so plus 4, 2 here, 2 cube is 8 by 3. Then minus, x is minus 1, minus 1 square is 1, so 1 by 2. X is minus 1, so that is minus 2. X is minus 1, minus 1 cube is minus 1. Minus sign is there, so minus minus plus 1 by 3. So you can simplify this. 4 plus 2, 6. 6 is 18. 18 minus 8. So that is 10 by 3. And this one is minus, like this is 6. So this is 3 minus 12 plus 2. So that is minus 7. So minus 7 by 6. So this is equal to 10 by 3 plus 7 by 6. And simplify this, you will get 9 by 2 square units. Next, find the area enclosed by the ellipse x square by a square plus y square by b square equal to 1, and it asks above x-axis. Okay, that means half of the area. So we have the ellipse like this. So this point is 0, b. This is 0 minus b. This is a0 minus a0. This portion we need to find the area. So here also let us, so this curve is x square by a square plus y square by b square equal to 1. We can take the horizontal or vertical any kind of strip. That means limit of y first or x first, not a problem. If I take the limit of y first, then the limits y0 here and y on this curve. So we can say that x square by a square plus y square by b square equal to 1. So y square by b square equal to 1 minus x square by a square. Or you can say y equal to plus minus b root of 1 minus x square by a square. Or you can say like b by a root of a square minus x square also. So, but here on the positive side, so we write y equal to b by a root of a square minus x square. And x is from minus a to x is a. Here x minus a and here x is equal to a. So we have required area a equal to, now y equal to 0 to b by a root of a square minus x square. X is minus a to a dy dx. So this is minus a to a, integration is y, 0 to b by a root a square minus x square. This is equal to minus a to a. This is b by a, the root of a square minus x square dx. And this is even function. So we can write this is 2 times b by a 0 to a root of a square minus x square dx. You can directly use the formula, or you can do another thing. So if I want to use direct the formula, then it is 2b by a. This is the integration of root a square minus x square is x by 2 root a square minus x square plus a square by 2 sine inverse x by. If you can't remember this formula, then there is another way. You take x equal to a sine theta, and this will become 2b by a. Now when x 0, theta 0, and when x is a, theta, sine theta is 1, so theta is pi by 2. Okay. Then root of a square minus x square. So root of a square minus a square sine square theta. So that is a, so it is like this. root of a square minus x square is root of a square minus a square sine square theta. A root 1 minus sine square theta, so that is a cosine theta. And dx, x is a sine theta, so dx is also a cosine theta d theta. So this is a cosine theta, and this is a cosine theta d theta. So if I put here to b by a, when you take a, this will be 0. When 0, then because of x, that is 0. So this is both sides, this is 0. This is a square by 2. When you take a, sine inverse 1 is pi by 2. And sine inverse 0 is 0. So this is nothing but pi. Then 1a cancels, so 1a is remaining. B is there. This is 4 and this is 2. So pi ab by 2. Same way here also. This is 2b by a, 0 to pi by 2. This is a and a here. So that is a square. This is cosine square theta, d theta. And we use reduction formula. It is 1 by 2 pi by 2. So again, this is pi ab by 2. If you are given the whole of the ellipse, then this limit become y from minus to plus, minus to plus. And in all that case, it will be remain 2 times because even function, and you will get the answer as pi b. Okay, thank you.